Okay, welcome back. Now this is part 2. In part 2, we have again distance time graph. Okay. Now we are going to look at this question. We're going to study the graph very carefully. And can you find the speed during the first 6 seconds? Now for the first 6 seconds, it travels 30 meters. So the speed will be the gradient. So speed, right, will be equals to the gradient, which is 30 divided by 6. So it travels 5 meter per second. How do you know the unit? This is in meter. This is in second. Now, what is the acceleration when time is 2? Now, the answer is pretty obvious because the speed for the first 6 seconds is constant at 5 meter per second. So whenever the speed is constant, the acceleration between 0 to 6 will be 0. So anytime between 0 to 6, it can be 2, it can be 3, and so on. So here, you put A is equal to 0 meter per second square. The speed doesn't change. Now thirdly, what is the average speed from T12 to T20? Now they say average, okay? Because if I were to look at this graph, okay, this actually tells me that there is an acceleration, okay? The speed is not constant, okay? If it is a straight line graph, the speed is constant. Sorry, can I just bring down? This is a constant speed, 5 meters per second. This is 0 because there's no change in the distance. And from 12 onward, this is what we call a concave curve. That means that the speed is increasing. And that means that there's an acceleration here. So what's the average speed? So we need to find what's the distance traveled from 12 to 20. That means from 30 to 60, the average speed, remember, the average speed is the total distance traveled, which is 30 meters. Okay, and we divide by total time, which is 8 seconds. Okay, so we're going to get what we call the average speed, and it is 3.75 meter per second. Now, can I ask, okay, for this journey, right, is the speed uniform throughout 12 to 20? The answer is no. Okay, if you were to look at 12, okay, at the beginning, the speed is 0. But at 20, if you were to find a gradient, okay, the speed will be very high. In other words, it's not a constant speed. Okay, not? So, but the average speed is 3.75 meters per second. Now, I'm going to attempt part D. Now, part D is a little bit, you got to understand. Okay? Now, here we want to find the speed versus the time. Okay? Now, for part D, right, I mentioned from 0 to 6. It is traveling at 5 meters per second. So, it is uniform throughout. Okay? Now, however, okay, at 6 to 12, we know that it is not moving. So, we know that the speed is 0. So, we got to draw here. My question is, how do we draw from 12 to 20? Okay, now the question, they actually said that the speed increases uniformly between T12 to T20. And at T20, the speed is 8 here. This is what they mentioned. So how do we draw the speed from 12 to 20? Okay, so we know From 0 to 6 is 5 meters per second. 6 to 12 is 0 because it's not moving. And we know that it increases uniformly, and at 20 seconds is at 8 meters per second. So we know that we got to draw a straight line from here to here. I did mention just now that at time 12 the speed is 0. So we start from here. Now this is the end of part 2.